Okay, Assalamu alaikum warahmatullahi wabarakatuh. Today we are going to learn about specific properties and specific enthalpy. Before that, let's start our class with Kitab Al-Fatiha. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين. Okay, after learning about this topic, we should know how to read steam table, where later on we will use steam table to solve energy balance problem. Okay, so before that, we should know what is intensive and also extensive properties. Okay, intensive properties, independent of the quantity. Okay, let's say if I have a glass of water, I have the density of the water which is equal to 1000 kilogram per meter cube. And also I have the temperature of the water which is 25 degrees C. Okay, then I take 1/3 of the water and transfer to another cup. Okay, later on if I ask you what will be the value of the density, it is still the same, 1000 kilogram per meter cube. And also the temperature is still the same, 25 degrees C. So, which means temperature and also density is independent of the quantity. Okay, now we go to the extensive. Proportional to the quantity. Examples, we have mass, volume, mole, mass flow rate, volumetric flow rate, molar flow rate, kinetic energy, potential energy, etc. Okay, so if I give you 1 cup of jelly, okay, and then I ask you to take 1/3 of the jelly and put it in another cup, okay, and then I ask you what will be the mass of the 1/3 of the jelly. So it will be 1/3 from the initial value. If the initial value is 30 gram, so the amount of mass that have been transferred to the cup, to another cup, is 10 gram, which is 1/3. The same goes to the molar flow rate, mass flow rate. So it is proportional to the quantity. Okay, and then for kinetic energy and also potential energy, since in the formula we have, for example, we have kinetic energy, the formula is half mv squared. So inside there got m, which is mass. If we have less mass, which means we have less kinetic energy. More mass means more kinetic energy. Okay, the same goes to potential energy. The formula for potential energy is mgh. So if you have more mass, means more potential energy. Also less mass means less potential energy. Okay, now we go to the next slide. We have extensive versus intensive properties. So we have learned before that extensive properties, if we take something from it, the value of the property or parameters that we are observing will be different, such as total volume and also total internal energy. Whereas for intensive properties, if you take several amount from the system, the parameters value will be the same, such as temperature and pressure. Okay, now if we have mass, density, melting point, length, and also color, if I ask you which properties belong to extensive property, so of course the value will be mass and also length, because if we have a rope, okay, and then we cut it into 2 pieces, the length will be half, so it will be different from the initial length. The same goes to if we have a bowl of jelly, we remove half from it, so you will have mass of half from the total mass from the bowl. Okay, now let's move to the specific property. The formula is extensive property over total amount of processed material. So this is called as intensive property. Okay, as we learned before, intensive property means if we take any amount of the parameter from the system, the value will still be the same. For example, we have V of a fluid 200 cm cube, where we know that volume is extensive property and the mass is 200 gram, also extensive property. Thus, the specific volume of 1 cm cube per gram will be obtained if we use this formula. So this property, the specific volume, is considered as intensive. Okay, now we go to the next example. If we have mass flow rate of 1000 or 100 kg per minute, which is the extensive property, and kinetic energy of 300 joule per minute, which is also extensive property, thus the specific kinetic energy will be 3 joule per kilogram. And this is intensive property. In other words, mass for this case and also mass flow rate for second case will be the total amount of a process material. Okay, so if we have anything that is divided with the total amount of a process material, such as mass and mass flow rate, we will have specific property, where it is known as intensive property. So in steam table, we will read specific volume of water, specific enthalpy of water, specific internal energy of water. Not only water, but for steam and also saturated steam, superheated steam as well. Okay, let's proceed to the specific enthalpy formula. The formula is H equals U plus PV, where U is the internal energy, P is pressure, V is specific volume. Okay, H is specific enthalpy. For example, if we have the specific internal energy of helium at 300 Kelvin and 1 atm is equal to 3800 joule per mole, and the specific molar volume at the same T and P is 24.63 liter per mole, calculate the specific enthalpy of helium at this T and P. So, in this case, we can use the previous formula that we have learned, which is this one. Okay, H equals U plus PV. Okay, we go to the solution. Okay, now you have H. You need to find H. You already have internal energy, which is given in the question. You already have pressure, which is 1 atm. You have the specific volume, which is 24.63 liter per mole. Okay, you can find the enthalpy by converting the unit for this situation. Okay, because this is not in SI unit and also this is not in SI unit. What we need to do is we need to use the relationship of R values, where we have 8.314 joule per mole Kelvin, and then we divide with 0.08206 liter dot atm mole dot Kelvin, and then we can cancel out mole Kelvin and mole Kelvin for this part. We can cancel liter and liter here, okay, and atm for atm. Then what we left is joule per mole, which is the same with internal energy unit. And then if we solve this, we will get 6295 joule per mole. You can try to do it. Okay, try to do the unit conversion and then try to get this answer. Okay, now let's move to the steady state open system energy balance. As we learned before, first law of thermodynamics for an open system at steady state tell us that we have input equals output, because we don't have the accumulation term. Okay, so input is total kinetic energy, total potential energy, internal energy entering the system with process stream, and then we have total energy transferred to the system as heat Q. Transferred to the system means positive Q. Then for output we have the same, total kinetic energy, potential energy, internal energy, living system with process streams. And also we have total energy transferred to the system as work, where we have positive work here. So what we have is 3 input and 1 output, where the input will be heat, work, energy input, and we have output, 1 output, which is E output. E output we obtain from this part, input we obtain from this part, and also this part. Now we are going to derive and find a formula for an open system. For the energy balance for an open system. So we need to evaluate the energy summations, where initially we have energy equals internal energy plus kinetic energy plus potential energy. Since this is open system, that's why we have dot here, and also dot here, which refer to mass flow rate. This is something that have flow rate. Okay, and then if we plug in the formula, after we consider the mass flow rate, we can rewrite the formula as mass flow rate times the internal energy plus with mass flow rate times with kinetic energy, which is U squared over 2, and mass flow rate times with Gz, which is the formula for potential energy. In other words, we are factorizing the mass flow rate from this specific formula. Like I have explained before, specific means we refer it to the total amount of the system, where in this case we use mass flow rate. That's why we factorize mass flow rate from this formula, where we have mass flow rate times with internal energy plus U squared over 2 plus Gz. And from the previous slide, we already have this formula where E outputs minus with E inputs equals Q plus W. Initially, the input is on the right hand side. Then we move to the left hand side. Then it will become like this. Later on, we are going to substitute this whole term, which is the term for E, inside this equation. Okay. Later on, we will see what will happen. But before that, we need to edit the work term, where we already learned that for open system we have shaft work and also flow work. Then if we expand the formula, we will have shaft work plus with output flow work minus with input flow work. And then later on, we are going to substitute the work term here inside the formula that we have obtained previously. Okay, let's see what will happen if we substitute W and also E inside the formula here. What we will get is this expression, where this is the total energy output minus with total energy input equals Q plus W. Okay, because I already mentioned we need to substitute the value of W with the value of flow work and also shaft work, where this is the term here we get from the previous slide. That's why we have this term, and if we rearrange the formula here, where we bring MPV to the left hand side, MPV for output, MPV for inputs, we will get this expression. Okay, see, we have Q plus W left, WS left here, after we move E output and also E input here. And then this is equal to enthalpy that we have learned before, U plus PV. And then we can simplify this formula, because this is enthalpy, this is kinetic energy, this is potential energy, and then this is output minus input, where we will have delta H plus delta EK plus delta EP equals Q plus W.